Okay, if you've got the old one, like the first PLC Advanced one, go ahead and open it up. If you don't, then the stuff we make in it, you'll need to go back through, watch the other video to make the tag table going forward, but this has it, right? We'll use that kind of as a template. So you just open it up, and then the first thing you do once you go into project view is save it as something different, right? So we'll just make that 1 into a 2, okay? So when you open that up, let me make sure I've got audio. Check. Okay. So open up project view when it opens and go up to the top under file and do save as and change that 1 into a 2. It's project. Save as, then change that 1 into a 2. All right, so if you don't have the first one, the things you'll want to watch in the other video is all the things that you need to put into the tag table. Yeah, let me go on. Is it up? All right. If you don't have the first one, like you can't find it or whatever, you're gonna have to go in and make a tag table. Like we'll see. We'll call that different things in different classes, but you want a tag table that's gonna have your analog inputs, outputs, and all your digital inputs and outputs. In main, all we had was where we took that function block now my computer wants to be slow. We took that function block in and we were able to convert analog in into like a voltage reading, right? When y'all did the lab, did it work for you? Okay. All right. So that's pretty legit. Like we'll leave that function block so that if we ever want to use it again, we'll just drag it in. We might add to it or whatever. The great thing about a function block, especially if you're able to use those local inputs and outputs, is let's say that I screwed up on it or I wanted to change the functionality of this. If I go in and change it in here, and I have it like copied over 10 times, it's going to change it over 10 times, right? So if I have to make any corrections to a mistake I made, I only have one place to look. Like if I did this every time I wanted to normalize and scale a vector, I would have to go and find every time I did that and change it, all right? But if I do good programming habit and compartmentalize things, and make a function out of it, no matter if I have that 100 times in my program, I've only got one place to actually look to fix, okay? So we're going to leave that function block there because we'll need it later, but we're going to take it out of main. Like we're not going to do anything with that function block right now. All right, so go ahead and kill that out of there. Make sure that you saved it as 2 first, because you'll need those function blocks in the first lab.
Can I make a copy of it?
Well, when you do a save as, you're doing that. Like it's keeping, like if you do a save as, then you still have advanced 1. Okay, then rename it back and then do a save as. Because what happens is it'll give you a full folder. Like if you look right here, I need to clean up my desktop, But instead of just having one folder with a bunch of stuff in it, like now, I have a separate folder for 2. I can't find it right now, but
It was right there.
all right. So are y'all in digital too? Mm-mm. Are you in digital? All right. Well, we're going to learn a couple of little things. When you've got a lot of networks, the way they process is fairly lateral or parallel. Like, these are going in such a quick round robin that you could think of them as happening at the same time, right? If you have a logic going on there, you got some logic going on there, you got some logic going on there. When it does that read cycle, it's like everything happens at once, right? There's very little one after another processing, okay? But a lot of processes, we need one thing to happen before another thing, okay? So I use the example of a machine that makes donuts. Like, you push a button, like, you got to make sure the oil's hot enough. So you got to heat up the oil before you start throwing, batter into it, right? So, practically every, machine that you build is going to have some kind of sequence to it, okay? In Allen Bradley, we've got what's called a sequencer. And what it does is every time you hit the input, it's going to do the next thing in that sequencer, okay? We're going to build one in Siemens. All right, so we're going to make something that does one thing the first time you hit it, then it's going to do something else when you hit it again, something else when you hit it again, okay?
All right, so I'm at the PLC folder.
Okay.
I'm at mine. So
All right, clear off that folder.
clear it out.
Just close off the folder part. All right, go to project, go to project view down in the left-hand corner. Go up to project and save as. Did you get it or no?
It says there's a PLC Advanced 1 and a PLC Advanced 2, but I didn't make it. 2. There is a PLC 1 and 2 in there at the top.
Okay, ignore that part. Just go down to the project view on the bottom left and open it up. What's it say across the top? You don't have like the C user, all of that. All right, let me come check that out real quick. It's going to give you a whole different path and a whole nother folder.
Now I can go into what we did.
Yeah, just delete what was in main. Don't actually delete the function block because we might need to use it at a future time. Okay. All right, so Allen Bradley's got a native sequencer, but it's not very hard to build. And I actually like building it because it makes it so that you understand what's going on a little bit better, right? So even if something's a network 1 and we've got a network 40, you could think of them as being run in parallel because they're doing it in a round robin fashion so quickly that it's not really, one's not really going before the other, in the greater scheme of things. We want to make it so that we can make a sequencer. We want it so that one thing happens the first time it goes around, another thing happens the second time it goes around. Okay. Now, in advance, we want to get away from just throwing everything into main. Okay. Like we want to do it in function blocks and the like. And then once we get those right, put that into main. Okay. So go to add new block. Go to function block, like click the second one, and up top where it says name, put SEQ for sequencer. Okay. Make sure it's language ladder, like you can do a function block diagram or a structured list, but we're doing it in ladder. Click OK. And that's going to give us a new place to put stuff. Okay. So we're going to make a super simple one. Have y'all dealt with the counter yet? All right. So let's drag a mystery box down there, and then let's put in CTU in that mystery box, and it'll be a counter, an up counter. Okay. Push enter, and it's going to
single instance, multi-instance, or parameter.
All right, so we're putting this in a function block that we're going to call from different areas, right? If we put it in a single instance, what's going to happen is whatever number's in that counter is going to stay in that counter every time we call it. So if we call the sequencer once, like let's say we have multiple calls of it from different spots, right? And it counts up to 3. Next time we call it, it's going to have 3 in there. It's not going to be a completely different one, okay? A multi-instance is, if you call the function block as a multi-instance, it saves its data in the instance data block of the calling function block and not in its own instant data block. This allows you to concentrate the instance data in a single block and to get by with fewer instance data blocks in your program. Okay, that's one. Parameter instance is where we're going to be calling it like variable wise. If you call the function block as a parameter instance, the function block saves its data in the instance you specify as block parameter and not in the instance of the called block. This gives you the option of defining the instance for this FB called during runtime. Okay, so let's put it there. Like, you know how we did the local ins and outs? And then when we drug it in there, it asked us for a data block. This is kind of what we're doing. Okay. All right. So we've got basically a local instance block of here. Like, it doesn't have any memory yet, right? We'll need to allocate that when we call it, because like the PLC doesn't know if we're going to use this once or a million times. Okay. We might need 1 million instances of this counter up. Okay. All right. So the CU input, what it does is it counts up, it increments a variable inside of it every time you have a low to high transition. Oh, we're doing parameter on this one. All right. So we need to put a normally open contact right there. Okay. And what's going to happen is every time we trigger this, it's going to increment the value in the counter. Okay. So if we push that button 12 times, it's going to increment it 12 times. Okay. Reset takes it back down to 0. Okay. We'll talk about that in a second. CV is our current value. All right. That's a variable that we have that is going to increment every time we go up. So it's going to start at 0. When CV equals whatever we set in PV, then Q is going to go true. So if I'm like, I need 12 pieces in this box, it'll count up to 12, and then it's going to turn an output on to tell us we got 12 pieces. Okay? So we need some form of output on that side to let us know that we got up to that point. Okay? All right. So every time this has a low to high transition, it's going to count up. All right. I don't want to generally hard code stuff here. Okay. Because if I hard code stuff here, then I'm not going to have it be particularly useful to use it more than once. Let's say I want to put the sequencer in. It's supposed to count out 10 things, or it's supposed to do 10 things. If I've got a 12 hard coded into it, I've got a problem. So that preset value, let's make it a variable that will tell it what it needs to be later. Okay. So what would that be in a sequencer? Let's call it steps. How many steps do we want this sequencer to have? Okay. All right. So type in steps under preset value and then right click it. And instead of jumping to a global memory, we're going to make this a global N. Okay. That means that we're going to tell it how many steps this sequencer is supposed to have. All right. And it's going to be an integer. So local N, booyah. All right. We want to be able to trigger that, like trigger the next step. Okay. So let's just call this one trigger, and it's going to be a local N as well. Okay.
Yeah.
Well, it should be a Boolean because it's only a true or false on that one, right? But it's going to be a local N, and it would be under Boolean. All right, for the coil, what we're going to call this is let's call it SEQ underscore finished. And that's going to be a Boolean, but it's going to be a local output. Okay. All right. And what are we going to do to make it so that one thing happens after another? All right. So we've got a counter that's going to start counting up 0, 1, 2, 3, right? Well, we'll like whenever we tell it that it's only got 10 steps, it'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And as soon as it hits 10, it'll hit the sequence finished, right? And we can reset it at that point if we want to, so it starts back over at 0. But we're not going to do that yet. All right, we're going to test a few things. So right here, let's just call this reset, or SEQ reset. Okay, SEQ reset. Now you're going, all right, so why are you doing this when you could just put that counter in up top? Well, we're going to add more stuff to it. Okay, so this will be a local in. So we're parameterizing practically everything on that counter so far. And we could have just put the counter in main. But once we start adding the rest of the networks, it's gonna work. All right, what's our count value actually equal? That's gonna be the step that we're on, right? So let's call that step, all right? And then we're going to define that tag as a local temp. All right. And an integer. All right. So as we start counting up, we're going to get a unique current value as we're counting, right? And we can use that counter value to trigger stuff. So what we're going to do is we're going to go over here. Well, let's just put a mystery box here on the second network and type in 2 equal signs. All right, so the 2 equal signs is the same thing. It's a math function. No, it's not. It's a comparator function. You got CMP equal to, not equal, greater than or equal to, less than or equal to, yada, yada, yada. So this way we're able to, this is still a Boolean. It winds up giving us a true or false based off of if these two things up top and on the bottom are equal. Okay? So let's put step up top, not steps. Steps is how many total we've got. And then we're going to put 0, or let's put 1 down here. Okay? All right. So we want it so that we've got a little spot so that on step 1, something will happen. All right. So what we're going to call this is step 1. And it's going to be a local temp. It's a local out. Let's make that a local out. Okay. It's one that like it's two-way communication. Like if you put something in, you can see the value in, or it can seed it back out. Let's copy this a couple of times. Let's do like 4 steps. So we're gonna like, you don't even have to click on it. Like you can just, as soon as you drag it in, then you'd start typing in step, and then we're gonna say 2, and then we're gonna make a step 2 local out. Well, like if you're not careful, like start putting in step 2 and then click over to the side, because if you push enter, it's going to try to force that step 1 into there. Define that tag local out. Oh, instead of local temp, you put local static. Which one said that? Like down here? All right, so like, let me throw another one in there.
Network 1, what you put for
local temp. You might have accidentally put local static. All right, so if you need to get rid of that, you can hit this little arrow up here, and then wherever you had that, right click it on there and then do delete. Right click on the little blue arrow and delete it, and then do it as a local temp. Is it in the static part of yours? Okay. Okay, then what that means is, did you name your PV step also, or did you name it steps?
The hashtag step for step.
Okay, so for PV it should be steps, and then for CV it should be step. So it's got the same name for both of them, and it shouldn't.
Icon that we just used in network 2, that first one, that thing we put step on. What is that?
That's a comparator, like, so just start typing in 2 equal signs.
Yeah, open circuit or that or the mystery box.
Yes. Wait, for steps?
Yeah, for the top.
This one. Okay, for step, that should be a local. Yeah. No. That should be a local. It was on your local there.
No, it's on local.
Okay.
So she's out.
Okay.
Oh, wait.
So all your like steps is the total number of steps that you're going to do before you want it to reset. All right. And then step 1, step 2 is a local out that you're going to do something with later. Okay. So let's go ahead and put step 3 in. So we'll do if step is equal to 3. And we'll call this step 3. That's going to be a local out. I'm going to say step equal to 4. And we're going to do a step 4. And while y'all are doing that, I'm going to go get a little PLC so that I can kind of show this a little bit. Okay? What you need? Come over.
Yeah, it took me a minute to figure it out too. The mystery box equal.
Oh, and then we step up here.
Enter.
That's what I was.
And it's
good.
enter. 5.
We're going all the way up to 5.
Yeah. Or 4, sorry. Network 5.
Little flathead. Little tiny.
I got one.
Like in that closet, the bathroom over on my side. You know what I'm talking about? I don't know if it works, though. Actually, this is gonna suck for a second. Because my screen's gonna go out for this. But what I'm gonna do is I'm gonna give this PLC a static IP address so that we can put it on the network. I can just program it from here from now on. Okay. So, my desktop or my laptop that's doing the screen right here is probably going to go out for a second. There's just a lot of people missing today. I'm gonna have to they're showing up for labs and they're watching the videos, so I mean
What's your wife do?
she's a GIS specialist.
Yes.
Yeah, she's
All I can tell you, well, you got that thing going on. What's going on?
all right, so all I'm doing is I'm putting the IP address as 10.11.160.60, and that it should listen to the router 10.11.160.254, so that whenever I put this on our network, it can actually communicate with me through the network. All right, so I'll right click it. It killed my computer because I've got my computer programmed or hooked up to the wall, so it'll be faster over here. I'll show y'all what I did after I get it on the network. We want to see if plugging it into that jack. Some of our jacks are hooked up to our 10.11 160 network. Some of them are. I'm hoping that one is so that we can actually see the PLC we're talking to, but it doesn't matter. We can leave it in the other room if we've got to. All right, so I've got this working. I will go and plug this in to the wall over here. And I'll show y'all how to do this.
That's the router.
Yeah, like it's gonna go through our switch, through our router, probably all the way out to Jasper, then back.
Really?
Probably. But then I should be able to just program it through the network now. We're about to find out. Let me go and refresh this real quick. Okay, so I'll show y'all what I did there, but let me make a change here to see if we're actually programming it. All I'm going to do is I'm going to put an output right here, and I'm going to not have any logic in front of it. So the first LED should turn on if I program this. All right, so let's see if it can actually find it first. All right, so it's going out. Huh, they found it. So the little green LED on there should show up. Did it come on? All right, so I'm able to program that now. All right, without actually being connected to it anymore. All right, so all I did was I went under device configuration, and I needed to make the PLC talk to our network nicely. Okay, our network is a 10.11.160 network. That's our personal little, subnet of addresses that we can use. I gave it a static IP address, like this 10.11.160.60. Nobody else can use that, or it's going to conflict. Okay, the subnet mask is just telling it what to listen to, what's on my same network. If I've got a 255, that means listen to it. If I've got a 0, those numbers should be unique. Okay. All right. And then what's the router? Who do I have to ask permission to talk to you? And that's 254 is the address of our router. All right. So is that showing up on the screen up there? Okay. All right. So we'll do that more and more because it gets, yeah, let's say you don't have to go grab a big green Ethernet cable and go sit near it. You could program any of those PLCs up there if they've got the right, so that makes it so it's listening to us. All right, so we've got this sequencer block. And all right, so click on main real quick. And then we're going to drag that sequencer block in. And it's going to ask us to make a call options. Okay, so we've got sequencer database. Okay, that's cool. The one that we just made, it's probably going to be under analog scaling. It's the thing that we just made. So we made that into all right, so you've got to be in main, and then you just grab it and drag it over to a line. So I'm going to delete that one.
Single instance.
Mm-hmm. All right, so I can start wiring this up. Now, right here, we've got to give it a new data block to work for that counter in there. Okay, so let's just say CTU1 right there. Right click it.
Mine brought over sequence finished in step 1, but didn't bring up step 2, 3, 4.
Okay, make sure that on your sequencer block that you have the rest of those in.
Yeah,
You do?
yeah.
Make sure those are local outs. Yeah. I may have been wrong about that counter. So what we want to do, we're going to test this out. We're going to put another counter in there. CTU. And then we're going to try that multi-instance. And then I'm just going to drag everything over there. And then delete that. And we're going to see what happens if that actually does what we want it to do. If not, we'll figure it out. All right, so right. It's doing the same thing. I need to give a counter instance of this. And I thought the multi-instance would do it.
It's fixed.
All right, so single instance, if you call the function block as a single instance, the function block saves its data in its own instance data block. If you call the function block as a multi-instance, it saves its data in the instance data block of the calling function block and not in its own instance data block. This allows you to concentrate the instance data in a single block and to get by with fewer instance data blocks in your programs. Parameter, if you call the function block as a parameter instance, the function block saves its data in the instance you specify as a block parameter and not in the instance of the block called block. Okay, I think maybe we'll just leave it as multi, and then we'll fix it. All right. So I don't have a switch on that PLC. So what I want to do is I want to make something that's going to keep triggering it. Okay. So have y'all made an oscillator yet? All right. An oscillator is a normally closed contact, a timer on delay. It's a normally closed contact, a timer on delay. So whenever this gets power, which is normally on, so it's going to get power as soon as we turn on the PLC, it starts counting up to a preset time. So we're going to say, let's say 1 second. Okay, cool. And then whenever that goes on, this will go high. We're going to call it OSC, and we're going to define this tag as a global memory. All right. So as soon as we get power, since this is normally closed, it counts up to 1 second and it turns this oscillator light on or output on. If we tie it to this so that that is the same thing, this is false to start with. Power comes on, it goes through here because it is false. So it's going to stay closed. It's going to count up 1 second, ping this on. As soon as it pings it on, it opens this up, which resets this and starts over. Okay. So we're going to put this oscillator on this trigger right here. All right. Let's say it's got 10 steps. All right.
Four box. What was that? Was it a mystery box?
Do a mystery box and then a timer on delay, a TON. A global memory. Yeah, it's going to be the same one. So once you make one, go and start typing it in OSC, and it'll pop up on the other. Yeah, we're going to put the oscillator on the trigger so that every second it's going to count up. Mm-hmm.
Oh wait, yours is in 8. It's in 10.
It doesn't matter. It's just give me the first available memory location, and yours might.
It's 10.
Yeah. All right. So we've got this red sequencer data block. So let me go and I'm going to right click that and update block call. If you've got any red on there, you need to update block call. I'm going to go back in there because that counters. Do what? That's only red. And that's my red because, like, I've got to figure out what to do about this instance block. Like,
Right click the sequence block and update.
block call. Yeah, it's down. Like, it's down about halfway down. So. All right, this is going to work like what we're about to do, but it won't let us like do multiple instances of this. So I'll figure out how to fix that and we'll come back to it in a minute. But like take another mystery box, do a CTU for another count up, and we're going to do a regular instance call of that, a single instance. All right. And then just drag everything into there in the same spot that it was on the other side, and then delete that multi-instance. All right, I'll do it again. Take a mystery box, put it down. All right, start typing in CTU. All right, and then do a full single instance. All right, so click OK. All right, and then drag these variables over to the it.
Over to the R. Got it. Steps over to the E. Got it. Delete this box.
Delete this box. All right. Now, when we go back to main, we're going to have a red little thing on, well, I don't know why. Okay, I know why. All right, now go back to your sequencer. Open up this, and where you've got
What box is that?
The arrow pointing
Yeah, very up top. Like up here. All right, so we got counter instance 1, counter instance 2. Which one were we looking for? DB6. We need to delete these. All right, so delete that under in out, delete those two counter instances off of there. And then go back.
14.
Yeah, so the 2 under static and the 1 under in out.
All right, so temp and step under static, 17 and 18.
No, it should just be it'll say like IAC counter instance. Leave step under temp.
Step under temp.
Yeah. Just nothing under in out, nothing under static.
Okay, I got it. All right, that's what I got.
All right, now when we go back to main, we've got to update that block call because it's not representing what we've got in there anymore. All right. So we've got the oscillator triggering that. And then if I program this in every second, step 1, then step 2, then step 3, then step 4. Now, I'm probably going to have all faults on there anyway, because by the time I get it like uploaded to the processor and then turned on, it's probably already past step 4. Okay. So I'm going to try to hit it quick. All right, so sequence finished. It's already finished. All right. So what we want to do, I'm going to go offline. And if step sequence is finished, let's put a finished here. Okay. And then we're going to make that a Boolean global memory. All right. And then over here on sequence reset, let's put that finish back in.
Global memory.
Yes. So what's going to happen is it's going to count from 0 to 9. And as soon as it hits 10, it's going to go over here to the sequence reset and reset again and be back at 0. So it's going to keep counting up. Like, so we'll be able to see it after a second. All right. All right, so you'll get back around. See, true, true, true. And then it's going to go to 5, 6, 7, 8, 9, 10. And then watch when it gets back over here. True, 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 true. And then it's on 5, 6, 7, 8, 9, 10. All right. Now, the problem with this sequencer block is we cannot use it over and over again yet because we've got a counter that is staying a certain number. Like right now it's on 2, step 2, step 3, step 4. If we try to recall that counter, we're going to have 2 things trying to deal with the same instances. Well, you can't download it yet because you don't have a PLC yet. All right. Yeah, this is what y'all do in the lab. Okay. And what you'll do is, what time is it?
I think I need to get another hard drive and save this one.
You can save it on there, and then when you come back, just save it onto your hard drive. Or if you promise me that you'll take them off after this, but nobody ever does. Nobody ever erases them afterward. Do it? No, off the computers. That's why I get people to do the jump drives, is because I'll be like, y'all can do it and save it onto the computer, but delete it after you're done. And nobody ever deletes them. So then I wind up with like, because these are big programs. They take up a lot of space. All right, so we've got a sequencer going on, right? All right. So like if we go into sequencer and we look at what's going on in there, we've got a trigger on the outside that's making this counter count up from 0 to 9. And once it hits 10, that's going to turn true. That sequence reset's going to be true. Boom. Right? So we're just going down that little list right there. So on step 7, you know, we don't have anything on step 7 or whatever. Right? So step 3, it'll keep counting up. And then it'll reset at whatever we decided the step number should be, right? Like, so if we go into main, let me go offline and go into main. I'm going to say that the number of steps that we want is going to be 5. Why I'm saying that is because if I put 4, as soon as it hits 4, it's going to skip back to 0. So step 4 is not actually going to work, right? So once I do that, then it'll just keep counting from, like, it won't have 0 in there, which we could do at step 0 if we wanted to, right? But it'll just keep counting from 1 to 4 and then back to 0 and then back up again. So so it's not like one of these is pretty much always going to be true other than on step 0, right?
What is the
that would like the sequencer block? All right. So in main, we've got this big thing called sequencer, right? Now, one of the good things about compartmentalizing your code is the fact that, like, as this gets bigger, look at how many lines of code are in here. Once I get this right, let's say I did like 20 steps in here. I'm not taking up that much room in main. All right. I make sure that function block is right and that it works consistently. And then I can reuse that over and over again. Yes. Like, so now, like, I've got it nice and compact in main. So I know exactly what this network's doing. Instead of having like 12 networks doing the same thing, I've got one box that's doing all of that stuff. And it makes it a lot easier to read. It makes it a lot easier to troubleshoot, because if I wanted to come in and I wanted to add, now this ain't going to work the same way. It's not going to work right because we got to take care of that counter. Okay. But once we take care of that counter, I could put 50 of these sequencers in and have them doing different sequences, right? And if I needed to make a change to all of them, I would just go back into that function block, make the changes, and then just go update those block calls. Okay. Now, let's play with, because what I want you to do is to be able to do this. I want you to be able to reuse a sequencer block over and over again. Okay. So the reason we can't right now is because of that timer in there. All right. So we need to figure out what that timer needs to have. Okay. So since I have it as a single instance, like that memory is, if I'm trying to write to that memory or read from that memory from a bunch of different places, I've got a problem, because one sequencer, it might be on step 2 and the other sequencer might be on step 8. Okay. So we need to make this make a copy of itself every time we pull it in. Okay. So what I'm going to do is, I'm going to show you how I find information quick. Okay. So it's Siemens, and I'm looking at the difference between a single instance, a multi-instance, and a parameter instance. The stuff in here is not telling me enough to get me where I want. So what I'm going to do is I'm going to Google Siemens single instance, multi-instance, parameter instance. All right. Instance, multi-parameter. All right. So, hello, I create a function block. There are codes created in ladder and FB1. Let's see. normally function blocks are simply multi-instance, like a function block that controls a motor. If you have 3 motors with the same control feedback setup, like, you know, a function block to control a motor would be called 3 different times with 3 different instance data blocks. Okay, so that guy's saying, all right, so home dude right here, like, I don't remember his name, but I remember his little avatar, like on the Siemens network. He usually gives really good information, okay? The difference between single, multi, and parameter. All right. Every call of the function creates a new database. Every call of the function creates an instance of that stat area of your actual parameter you define during the call of the function. I think it's going to be multi. Let's see what happens with the single. All right. So we've got a single here. Okay. We're going to go into our main and we're going to drag that sequencer back into here. Okay. And then we're going to say steps, or we're just going to do 2 steps right there. We're going to be reading off this oscillator. We're going to say step sequence finish. We're going to say finish 2. All right. Like, hold off on making this and we'll see if it works. And if it does, then I'll get you to make it. I'm going to make that a global memory. So sequencer reset, finish 2. All right. So if the timer or the counter in there is giving us a new thing, then these 2 things should be running separate, or, you know, without stepping on each other. What I'm going to do is I'm going to drag this up to this network so we can watch both of them at the same time. All right. Then we'll download. If we've got any conflicts, then we'll be able to see it because one of them's going to be spazzing out. All right, so I can already tell you it's spazzing out because, like, this one's trying to get up to, you know, step 5, but it can't, right? Correct? All right, now watch this. This is why it's, like, really freaking awesome. Because I've got a bunch of sequencer blocks, and they're screwed up. Instead of having to go fix all of them, what I'll do is I'll go into that sequencer block. I'm going to right-click this and change this instance. I'm going to change it to a multi-instance real quick. And then I'm going to go back to main. And I'm going to update block call. Update block call. All right. And then I'm going to download those. So it might have been the multi-instance, right? Reinitialize. Now, this is a thing that I want you to pay attention to if it shows up. Like, sometimes it'll show up a third screen that says, like, no action or start module. If it says no action and you don't change it to start module, it's going to stay yellow and it won't run, okay? So if it ever asks you, you know, that, make sure you got it under stop. Okay, so sequencer 1 is going all the way through those, right? Sequencer 2, boom, boom, is just going through its piece. All right, so if you're going to use anything that has an instance in it, right? Like that needs its own memory, but you're going to reuse that over and over again, put multi-instance because you don't want it overriding the same memory data block over and over again, okay? So where's this good? I could have a machine that, yes, you could put 100 of them, like,
But if you do single instance, you can only do 1.
if you do single instance on anything inside of it, you can only do 1 because that number, that counter is only going to be counting up 0 through 10, and it won't have multiple places for memory for the different spots that it's at. Okay. Parameter, I don't completely understand. Like, I'll do some more studying and I'll give you a better answer. Parameter is more like what we're doing right here, where we're saying we're going to give you some information, but we don't know what it is yet, right? So when we're doing like a local in, that's a parameterized. Like, that's saying, hey, don't give us memory here because we might use you 50 times and you'll have to allocate that memory later. Okay. And we don't want you stepping on the same memory location. So we give it a placeholder. Okay. And I think that's more in line with what the parameter data is doing for that data block. Okay. And it actually makes sense because remember when we called it and it had that on the outside where it was like counter instance? It wanted us to give it a reference to a data block that it would store its information in. Okay. All right. So we could do this 100 times. Like, that's the power of this. Y'all saw how I did one change, and if it was 100 sequencers, I would have just had to go update those block calls, right? All right. Do what? Yes. And if I know this works, like if I get one that works, then I don't have to keep reinventing the wheel. I don't even have to look back in here, right? Like, because when we put a counter in there, that's doing a lot of stuff. What it's doing is every time it gets a trick, like a low to high, it's taking the variable that we've got, it's adding 1 to that variable, and then moving it back into that variable, right? We don't have to see how the sausage is made. It just counts for us, right? They did the same thing to that function block for us, right? So if we make something like a motor starter, you know, like a one with seal in and everything on it, it makes it a lot easier to look at. Like, we don't have to see all the little math that's going on inside that counter, do we? No. And we know that if there's a problem, it's probably not in that box because that box has proven to us that it works over and over again. So I've got a few little functions that I built that I have in a template that I reuse over and over again because I know that they're not going to screw up, right? Like I've built the sequencer 20 times and it took me Googling to remember if it was a multi-instance or parameter instance, right? But if I need to use that because I've got my template, I could just drag a sequencer in and I know that it works because I was a lot smarter back then, right? All right. So when you get in there, what you'll do is, all right, so I don't have any lights on there. What I want to do is I'm going to make this my digital out 1. Okay. So it should just be blinking.
That second block.
Yeah, like, so go back into, all right, go back into your sequencer block, right click your CTU and say change instance, and then make sure it's under multi-instance and put OK. Okay. And then once you're done with that, go back to main and drag another sequencer block into there. All right, so the first one's going to have 5 steps. The second one's going to have 2 steps. Okay. And it does make sense because the steps are 0 and 1. We just don't have anything on step 0, right? I didn't want to input on that step 1. I want the digital out 1. Okay. Because I'm going to be making that light blink 1 at a time, just back and forth every second, right? And then for step 1 up here, we're going to do digital out 2, digital out 3, digital out 4, and digital out 5. Okay. Now, what's pretty amazing is it looks like you got 2 different things going on at the same time. You're going to have one that's blinking just on and off. And you're going to have 2, 3, and 4 that are going to sequence through. Okay? I'm going to go ahead and download that to make sure my code's right. I'm going to go look.
They're out.
Yeah, digital out. All right, so come look at these. So we're cycling through, for some reason, like, 4, digital 4 isn't showing up. But I think it's just because I probably put digital in on that one. All right, so let me, yeah, I put digital M4 on that one. All right, so I'm going to change that to digital out 3. Or digital out 4. And whenever I download this into there,
Block where it changes and has all of the,
yeah, right click the block and then go down to update block call. See, like up until this point when you're doing combinational logic, all that stuff, like combinational logic is happening concurrently, like, or at least too fast for us to see one thing happen before the other. Did that go out up there?
Yeah.
That back up?
Yeah.
All right.
what did you change on network 1 from I counter? What's a CTU? Where is it?
It's a counter up.
Yeah, it's counter up.
It's type integer.
It's there, but I don't have all my. All right. They're on sequence 2. Keep switching to name now. Network 1, that one's fine. Network 2 on that. Have the SB2 block. Sequence block.
Oh, you're talking about in main. All right, so that's what I got going on in main.
Oh, let's throw digital out too.
Because I wanted digital out 1 on the other sequencer just to be flashing. Like, so this sequencer is just going 0, 1, 0, 1, 0, 1. And every time it goes to 1, it's going to output digital out 1. So we're just going to have digital out 1 blinking. And the rest of them going in sequential order. Okay? So with your combinational logic, when you were doing, you know, your ands, ors, and nots with the normally closed and normally open contacts, you could think of those as happening parallel. Like all that stuff was happening all at once, okay? But we need sequences to make a job work. Imagine that we had a machine that you load a piece of metal into, and then it goes down and clamps it. And once it clamps it, then it goes through and it, you know, cuts out a piece, and then it unclamps, and then it shoves it out, right? We've got sequencers inside of sequencers, right? right? All right, so we could have like a master sequencer that was like step one of the job. All right, clamp it down. So on step one, instead of digital out two, it'd be going to the clamp routine, right? And then let's say network two was a clamp routine, all right? And then step two, it'd be going to the cut routine. And then like, you know, it'd be driving this other sequencer that would do things like on the cut job, right? So now you've got the ability to do things all at once with your combinational logic. And now you can do things that depend on something happening before it. Okay? So we get done with step one. Now we go to step two. Okay? Like instead of running with an oscillator, we could have something on step two that would say I'm finished, and then that would trigger it to go to the next step. Okay? So the sequencer is very important. But more important than the sequencer is learning how to do function blocks so that you can compartmentalize your code. Okay? So that it makes it easier to read in your main. And then if I know sequencer works, right? Because I've used it a ton of times, then if I have a problem, it's probably in the code that I've got around that sequencer. Okay? And how I've got it set up. And if I do have a problem with sequencer or I need to add a functionality to it, I can just go into that function block, add the functionality, and then update all my block calls. And I've got that new functionality in there. Okay. And have y'all done an oscillator before, like the one we built here? Okay. Like that's pretty important. We like an oscillator helps us take things out through time. Okay. Like you could think of it as a timekeeper. All right. Like the microprocessor in the PLC has an oscillator. Like your phone has an oscillator. Like basically it's driving us so that we like an oscillator plus a counter makes it so that we have something that's unique to each instance that we want run. Instead of, you know, are the switches in this particular order? No. It's like, is this the fifth time that the oscillator has turned in this sequence? Yes. You know, so now we've got a unique thing that we can call upon when that happens. Okay. You could finish out this oscillator, the sequencer, so it has 100 steps if you wanted it to. Okay. We just went with, 4 steps because we were, trying to get to a point where we could put it in main and actually see it work. When you get this in, what I want to see is a video of your code, and I want that digital out to be turning. Do what?
Dig out.
Oh, it should already be in your tag table. It's a global output, 0.0. Like if you need the tag table, go back to your first one, but it should already be in there.
So when we look it up on the sequence site, will it for the control? So it'll be flashing because sequence 2 is already on number 1, right?
Yeah, so the sequencer 2 is going to flash the first light on and off just constantly. And then yes, and then sequencer 2 is going to go 1, 2, 3, 4, and then it's going to not have anything because we don't have a step 0, and it's going to go 1, 2, 3, 4. So now you've got two things that are running. You could think of as concurrently, but they do have a time component to it, right? Like, digital out comes on before digital out 2 comes on before digital out 3 every time, right? So now we can make near about any machine that we want, right? You could build a custom sequencer for whatever. Like, I wouldn't build a custom sequencer. I'd build one that like I could use over and over again, but would have enough functionality for what job I needed it to do. So let's say that we have, we've got 2 cylinders. I'll go out and they'll push these little things down so that it clamps a piece of metal, right? And then the other sequencer turns on the drill and then lowers the drill, and it keeps it there for a certain amount of time, and it pulls the drill back out, right? And then boom, we unclamp, and then we have another cylinder to pop that out, right? So somebody loads a piece of metal, it clamps it, drills it, pops it out into the basket. He loads another piece, yada, yada, yada. Or a robot does, right? Instead of having an oscillator telling you to go to a step, we could have like a robot saying, okay, next step, or, you know, we could have other data driving this, right? What about this? If I had a faster oscillator, could I do it so that anytime digital 3 is out, that now all of a sudden this is doing something? So instead of this being on, you know, step 0 and 1, I could have this sequencer driving this sequencer, right?
In my sequence block, I have network 1 as sequence finished, network 2 as step 1, so on 3 as step 2, 4 as step 3. Somehow in my damn sequencing block, it goes from step 1, step 4, step 2, step 3.
Okay. If you've got it out of order, like, go to this little block right here, and that means that you put your step 4 in before you put your step whatever. So they're not going to be in order. Whatever order you put these in is what order they're going to be. So grab one of those blue triangles and move it up, or move it down to order those. And then once you're done, yeah.
On number 2, is there 4 steps, and you only have 2 in
On network 4 down here.
Yeah, you only put 2 steps in it, but it has 4 like outputs for it.
Oh, well, all right. So on the first one, I actually have it going all the way down to step 4, right? Now,
Oh, you just copied it from the
yeah. So all you gotta do, like, if I want to make another sequencer, all I gotta do is drag another sequencer down. Now, I could have 100 outputs. I don't have to use 100 outputs, right? Like, so I could have step 1 through step 550. And then I could have different things run off of those steps, right? Right here, I don't have to use step 2, 3, or 4 because I ain't doing anything past that point, right? That makes it more general use. Like, if I made it 2, then I'd have to make a whole nother sequencer for a 4 step or a 10 step or whatever.
So I changed the order of the block.
Go and update that block call. Like, is it?
I'll change the block.
See, I am pretty good. I can, like,
Talk through it.
without even looking at it, right? like you want to be able to do that, because if you're the only person who understands PLCs at a place and they're calling you at 3 o'clock to come in to fix something, if you can't do it over the phone, you're going to be driving, right? All right, so that's about an hour and 30 minutes worth of, watching me do something. And I think that y'all are going to have an easy time because y'all were here and, got to build it with me. I think it's going to take other people significantly longer if they're having to watch the video and then build it, right? So, all y'all will have to do is go in, download it into your device, make sure that's working, tweak anything that's not working, and you're done. Like the people who are watching the video, it's probably going to take them 2 or 3 hours. So it's worth it to come if you can. All right. And it's ridiculously fun because at this point we can start. At this point, with combinational logic and sequencers, you can build anything. We could build a traffic light right here if we wanted to. I might not even have like too much of a video next week. I might be like, all right, take the sequencers and combinational logic that I've taught you and make a traffic light function block. I think I might. All right. You think about, all right, what's the sequence? That's how you design a thing. All right. Number 1, northwest or north-south red, east-west red. Both of them be red. All right. And then whichever one we want to go to green first. This one has to stay red. And it might be good to put, some combinational logic that if something's screwed up and it try to put it green or yellow on both sides, you're in trouble, right? So if that ever happens, just go to red flashing or something, right?
So is this how they use the actual, make the lights? Is there a sequence on them every single time?
Like, started off it was with, okay, well, but the sequence isn't. Like, what the proximity does is it, like, goes, all right, stay at this for 5 minutes unless the inductive is there. So then, like, it might shave a minute off of it, or might shave, it'll half it. Well, a lot of what we're doing here, so like as opposed to this happening every second, we'd go to the next one green to yellow might be 3 minutes, but then from yellow to red might be, 5 seconds, right? But, it's a sequence. And now when we go push the button or we roll up something, that's ferrous on top of that little inductor in the road, then that might tell it, okay, at night, or if there's nobody at this, stoplight, you can stay red for 5 minutes, but if somebody's here, only stay red for 2 minutes, right?
That's pretty cool.
I think I might just get y'all to do that because you can build anything you want now. Like you don't have to build a sequencer for it, but you're building the same thing over and over again if you don't, right? You're building sequencers, you're just not compartmentalizing them. But like any machine is just a sequence of events. And if you break those down into little pieces, you can make it trigger to do whatever, right? Think about the traffic light, because I think that's what I'm going to get y'all to do next week, is build sequencers that are for a traffic light. All right, so we got red, red. We can never have a green, green or a green, yellow, right? Like ever. So we might put combinational logic that if the green light's on and like yellow or red on the other side cannot be on. It's like that electrical interlock for the motor control cabinet, right? Like you cannot have it forward and reverse at the same time, or you're going to blow it up. All right. The lights work, relays and timers and stuff. And then now, like a lot of places, like you can program them from somewhere else to get a flow of traffic so that if they're going the speed limit, they will only hit one red light through your town.
in Tuscaloosa, I saw,
Like if you stay at 45 miles per hour or something,
yeah,
like,
they had a program because there was like 10 red lights, right? And I saw it switch. It would be like a second, and it'd be like probably like 3 seconds in front of it. So this one would turn yellow, and 3 seconds after that, next one would turn yellow, and then keep happening like the same.
yeah. So
I guess that's how they keep it for people like running red lights and stuff like that. Probably.
yeah,
You know
and
it's gonna come.
like, and a lot of places will be like, if you go 35 miles per hour through this, you'll only hit one red light. All right. Like this makes it extremely powerful, but it's not too hard, is it? I mean, we just built a sequencer from the ground up, and all it is a counter and some comparisons, right? And all we're doing is it on step 2? If it's on step 2, like output to step 2, and then we don't care what we're doing on step 2. We'll care about that later, but this helps you look at one problem at a time, because now we've got a sequencer that we could add to and make a traffic light sequencer, right? Like instead of step 1, step 2, step 3, we could have north south red, north south yellow, north south green, and then red, yellow, green. And then all we have to do is just oscillate, and it's going to change those two things to be what they need to be. Yep. So this is where it gets exciting, because you've been like, instead of like having the tools to build a house, like you've been building those tools, right? Like instead of here's a saw and a hammer and all this, you've been like, here's some wood. Yeah, you've built your hammers and stuff, right? You've got all your tools. You can build, like with a sequencer and combinational logic, I can make with just combinational logic, but sequencer makes it a lot easier. You can build anything that you need, right? The robots are run off PLCs, okay? Like, y'all good? All right, let's cut out.